All right, in SPSS, running a one-sample t-test is pretty straightforward. If you want to ask if your sample mean, or if your sample seems to have come from a different distribution than you specified in your null hypothesis. So for this example, I've pulled open the testosterone and trust data set. It's a hypothetical data set. We're assuming that people have been given a dose of testosterone and then completed a dependent measure of trust, asking them to rate how trustworthy they think a stranger is. And we assume that the population mean for the untreated population on this measure is 100, so that if testosterone has no effect, that the population mean should be 100 for the people who have been treated with testosterone. So the question we want to ask is, for our sample, is there any evidence that their trust scores differ significantly from 100? And we've collected here a sample of 100 individuals. All were exposed to a small dose of testosterone before doing the dependent measure of trust. And then to ask if this sample gives us any evidence for an effect of testosterone, we're going to do a one-sample t-test. To do that, just click on Analyze, go down to Compare Means, and go to the one-sample t-test. Then move over your dependent measure, that's our trust scores here. It's the only variable in this data set. And at that point, you're pretty much good to go. The one thing you do need to remember for the one-sample t-test is SPSS doesn't know what the null hypothesis is. So it doesn't know what the population mean should be if there is no treatment effect. So here you need to enter a test value. This is the hypothesis mean from your null hypothesis. And recall that for this measure, we said that the population mean for the untreated population should be 100, that their trust score should be 100 if there's no effect of testosterone. Also for the one sample T, you can look at options. In this case, there's not much that we're going to worry about. 95% confidence intervals are fine. So yeah, this should be about it. Then you can just hit OK. And you should see some output here as long as you're set to show the syntax for your commands. And then you'll get some output here that's relatively straightforward. So for some reason this is labeling my dependent variable incorrectly. This is my trust measure. There are 100 people. The average trust score in my sample for my individuals treated with testosterone is 97.46. And recall that the population mean was 100. Standard deviation for the sample is 23.248. And the standard error of the mean, this is the estimated standard error of the mean, is 2.325. So if you had that information, you could calculate the t-statistic yourself, but SPSS has done that for you. The t-statistic is negative 1.092 with 99 degrees of freedom. The two-tailed significance, the p-value for the test, is 0.278. So this is the main information that we would need for class right now to say that the t-statistic was 1.1 essentially, with a p-value of 0.278. So the probability of getting a sample mean of 97.5 if the null hypothesis were true is about 28%. So about 28% of the time we could get a sample with this mean out of our population if in fact testosterone has no effect. So we'd say in this case that it looks like we should fail to reject the null hypothesis and say we really don't have much evidence based on this particular data set to say that testosterone had an effect. Later when we talk about confidence intervals, here we'd say our confidence interval of the difference for the size of the effect of testosterone is somewhere between, well, is between negative 7.15 and positive 2.07. So whatever the effect of testosterone is, it's somewhere between lowering trust by 7 points and raising trust by 2 points. So we're not sure. This is one of the reasons we would say that we're going to fail to reject the null, is we don't even have confidence that testosterone, say, either decreased or increased the population mean. So, all right, that's all we need for this case, and the testosterone data set is also going to be posted online if you'd like to do this analysis yourself. Oops, no, all right.